Okay, you're on.
All right, thank you everyone for coming here. We are sorry for the delay. We are Team SAP and we are here to talk about our project, which is a in-memory database empowered airline delay prediction, mobile app and service. So I have with me my teammates, Nikhil, Not and Lily, and we also have our client Jordan from SAP and our advisor Jia Zhang here. So the agenda for today is we'll go over the problem statement and then delve into the technical details, go over the back end, the middleware, the front end, have a very quick demo, and then talk about the methodologies we used and the challenges and some future work. So first let's go about the agenda and the problem statement. So the main objective of this project, the primary objective was to use SAP's in-memory database to solve a real-world problem and to showcase SAP HANA as a development platform and do it in one of the educational institutions, which is ours. So for those of you who don't know, what's HANA? So HANA is a next-generation platform from SAP, which is an in-memory database. So you can just imagine how much faster that can make things. So it allows real-time analytics, real-time applications, and real-time platform. So you can just think of HANA in terms of these 5 things. So it makes your life simpler because you don't have to go about doing distributed processing and things like that. It's high speed, it's in memory, and it's fast, and it's real time, and it lets you do both broad and deep analytics. And that's something that we are using HANA for right now. So our problem. So a lot of you might have been stuck in a situation like this. Stuck at the airport, don't know what to do, tired, flights are cancelled, flights are delayed, and that's exactly what we are trying to tackle. So our problem is, so this is not just your problem, but there are millions of passengers who are inconvenienced every day, and the airline industry loses billions of dollars every year. Last year alone, it lost $22 billion in this country alone. So you can just imagine how huge the impact of this problem is. And one of the major problems there is that there's no good prediction mechanism. So what we thought is if there is something like that, then logistics can be arranged by the airline industry, passengers can plan early, and maybe life can be simpler. So what we went ahead is to see what if we can predict delay with a higher accuracy and at real time so that people can react to it, people can plan early and do things. So first we went ahead to understand the target audience of such an application. So airports could do with such an application because they can probably reschedule the runways, make sure their flights are adjusted accordingly. Okay, there's a flight that's coming half an hour late, maybe this runway can be used by some other flight by then. Arrange some logistic. Okay, they need more chairs put in, maybe more food should be arranged at the airport. Simple things like that. Okay, there's a hurricane, so maybe, okay, more people are going to be stranded at the airport. You can plan some things like that if you know the airline delay prediction as a whole on an airport level. Then the booking agents. A booking agent can set different flights. They can offer services, coupons. They can say, okay, book this flight and it's guaranteed. So even if you have to pay a little more, maybe this is better for you. And similarly, insurance companies, they can do differentiated price based on predicted delays and say, okay, the delay for this flight is going to be more, but we're going to charge you more insurance for this, so it's up to you to take it or not. Then, of course, the passengers, something we all think about, who would want to pay more for guaranteed flights or change their destination plans, book insurance, and so on. Or airlines who want to minimize their costs for staff or other logistics, maybe arrange food, optimize their parking spots within the airport, and even to stay within laws. They want to ensure that their crew doesn't fly for too long that day and so on. The next thing we went ahead and did was a competitor analysis to see what's already there, what's there in this field to see, okay, who is actually solving this problem and who is trying to. Something that all of us do is just go on Google, type a flight number and see how delayed it is. But the thing is, Google doesn't do a prediction. It will say your flight is delayed if the airline has announced it, and an airline doesn't announce it until the last minute. And that's exactly what a lot of others do. There's flight stats, there's flight aware. Most of them have very nice UIs, very easy to use. You'll be really happy using it, but the thing is there's no prediction. So until your airline finally goes ahead and says, my flight is half an hour late, you don't get to know it. 2 days before the flight, you will never know it. And there are a few other applications, like there's no delay, which considers only weather delays. There's Inclicast, which only considers airport delays. Or there's Teleris, which considers flights mechanical delays, and they have tie-up with some airlines and so on. And there's Flightcaster, which does a few things, but there's a lot of complaints online which say, okay, this is very slow. So we thought, okay, there is really a huge vacuum in this space. There is no real-time flight delay prediction service available. And that's when we thought, okay, good, let's go ahead with this problem. And here's our solution. Use historical flight data, use weather data, combine the two, put it into HANA, make use of HANA's in-memory real-time big data analytics platform. HANA already comes with machine learning techniques, so we can learn, we can predict the flight delay. And then as a output of that, we give not just the delay output to you, but also a web service API for its easy integration. So that's really needed if you as an airline needs to use it. You don't want to sit and query every single flight in a, even if it's a mobile app. So we also provide a mobile app for passengers to use it on the go, and passenger services for added convenience. We'll talk about it later, but you'll actually see how services can be a true value add. So what we want to do is target these two segments, passengers and airlines. Airlines can integrate our system to receive predictions. They can minimize their logistics, they can stay within laws, schedule their flights. Passengers can get early information, make their plans. You can make your holiday plans by knowing, okay, even if I'm delayed, I can still make it to the other location next day, and let's have these plan B and plan C and so on. Book guaranteed flights or receive airport services and coupons. We'll talk about recommendations later. So now that you know what we're doing, we'll go into a little more technical details. I'll ask Nikhil to talk about the HANA backend that we're using.
Thanks, Devika. Hi, everyone. So I'll go over the technical details and especially the HANA backend part. So this is the overall architecture of our project. As you can see, it has three parts: the backend, the middleware, and mobile app. So this is where the HANA database part comes into picture, and these are the two aspects where we have explored HANA to the extent we want to. And so this entire thing, the entire backend part is what I'm gonna go into the details of. So once you have the data imported into the HANA instance, you do the processing of the data here, then you get the output. And once you get the output, you use the SAP HANA features to export the data, and then the middleware fetches the data and uses recommender. Like all these details will be covered by Lily later. And then we have the mobile app, which fetches the data from the middleware and then displays it to the user. So I'll talk about the whole backend right now. So here, so the first thing is about identifying the data. So when you talk about flight delay, it's about two kinds of data. One is the weather data, and the other is historical flight data. So that is what we have done, like historical flight data, we imported, and also the weather data. So the whole data is being imported first. Then after having the data, it's about processing the data. So the machine learning algorithms, training the data, and then getting the results.
Network connectivity was lost.
Oh.
Yeah, there it goes.
But I don't know if it's recording now.
It is.
Okay.
Yeah, so once you get the data, it's about the training the data,
It's
then
not
predicting the results.
Wait.
And after we are predicting the results, it's about exposing the data to the middleware.
Wait
so
a
that-
second. It's not recording. I need you to share the screen again.
From here.
Exit the diagnostics. Open a new window, meeting window.
With this link?
No, just click the link.
Sometimes.
The internet is really slow this
Yeah.
morning for some reason. So that's why it keeps losing connection.
Unfortunately.